Is x up to 3 greater than 1? Let us use one of the strategies to deal with data sufficiency questions in the GMAT. We need to reformulate, right? Restate this question in a simpler way, in a way that will facilitate the sufficiency analysis for each of the statements 1 and 2. So, what needs to be true about x for the cube of a number to be greater than 1? If you try several values, you will realize that what they're asking is just this. Any number greater than 1 would have a cube that is also greater than 1. It is more than just for a number to become positive, right? Because a positive number could be a positive decimal, but a positive decimal raised to the third power will not be greater than 1. It has to be greater than 1 for the third power to be greater than 1 as well. Okay, so this is our reformulated question. Let's go for statement 1. Statement 1 is a statement that can be formulated as an inequality. X squared is greater than x. Can we analyze this as a quadratic inequality, perhaps using property number 6? Remember, if you have this, ax squared plus bx plus c is greater than 0, provided that this a is positive, then the solution of this inequality is this, x less than x1 or x greater than x2, where x1 and x2 are the respective roots for the corresponding equation. So let's try to do this. Let's give this original inequality the form of the quadratic inequality. Now, let's proceed to solve the corresponding, the corresponding equation. X squared minus x, right? Equals 0. So x can be 1 or x can be 0. Because of this, we know directly that the solution for this inequality would be x is less than 0 or x is greater than 1. Of course, this double inequality would provide two different answers to the question. If we take values that are less than 0, we would say that these values are not greater than 1, giving a negative response. But for values greater than 1, we have a confirmation of what the question poses. So, two possible answers not sufficient. Let's try number 2, x is greater than -1. Okay, a number greater than -1 might be, for example, 5, which is greater than 1, but it could also be -0.5, which is not greater than 1, so not sufficient. How do we evaluate the combination of the two statements? When we need to take the two statements as true affirmations at the same time, we can understand that when a statement represents an inequality is an interval of values, a continuous interval of values on the number line. So we can do a graphic intersection because we are just crossing over the two ranges or intervals of values corresponding to the two statements. We need to see which values are common in these two intervals. So let's try on a number line will represent the values that correspond to each of the inequalities in each of the statements 1 and 2. Statement 1 said that x might be any negative number, that is something like this, or all numbers greater than 1. While the second statement says that x is any number greater than -1. And so we can see how the intersection of the two intervals is actually a double range of values. We have this and this. This first one can be represented by the inequality x is less than 0 and greater than -1, and the other one is all values greater than +1. So we have a double inequality. With the values on this range, we would answer a no to the question. While with this, we can confirm what the question is posing. So still two answers. Correct answer choice would be